There is a single assumption buried so deeply inside the human mind that most people never once question it. It is not a cultural tradition, it is not a learned belief. It is something far more fundamental than either of those things. It is the assumption that you are walking a single, continuous path through time, that the life unfolding behind you is the only version of events that ever physically occurred. That when a car swerved past you on the highway last Tuesday, the version of Tuesday where it did not swerve simply ceased to exist, dissolved back into some empty void, leaving only the version where you survived intact as the sole physical record of what happened. This assumption feels so obvious, so self-evident, that challenging it seems almost absurd. But theoretical physics, through decades of rigorous mathematical development, has arrived at a conclusion so structurally precise and so strange that it dismantles this intuition completely. The physics does not merely suggest that other outcomes were possible. The physics demands that they physically occurred. And once you follow that demand to its full mathematical conclusion, the nature of what you are, what death is, and why you are here experiencing this moment at all, transforms into something almost beyond ordinary language. To understand where this leads, we have to start at the foundation. We have to start with the equation that governs the behavior of everything that exists at the most fundamental level of physical reality. In 1926, the Austrian physicist Erwin Schrodinger wrote down an equation describing how the state of any physical system changes through time. The equation is linear. This is a technical mathematical term, but its implication is staggering. Linearity means that if you have one valid solution to the equation and you have a second valid solution, then a combination of both solutions is also a perfectly valid solution. The mathematics does not force the universe to pick one outcome. The mathematics describes a universe in which multiple possibilities coexist simultaneously, each one carrying a specific weight called a probability amplitude. A probability amplitude is not a probability in the ordinary sense. It is a complex number, a mathematical object with both a magnitude and a phase, and its magnitude squared gives you the likelihood of observing a particular outcome. But here is the critical point that changes everything. Before observation, before any interaction with the surrounding environment, a quantum system does not exist in one state or the other. It exists in a superposition, a genuine physical blending of all possible states simultaneously, each weighted by its probability amplitude. This is not a philosophical interpretation. This is the raw mathematical content of the Schrodinger equation, and it has been confirmed experimentally with extraordinary precision across more than a century of physics. Electrons pass through two slits simultaneously and interfere with themselves, producing a pattern that only makes sense if the electron genuinely traveled through both openings at once. Photons enter beam splitters and exist in genuine superpositions of reflected and transmitted states until they interact with a detector. The mathematics is not describing our ignorance about what is really happening. The mathematics is describing the actual physical structure of nature itself. Now bring this down from the atomic scale to your living room. Imagine you are standing outside on a warm afternoon, and above you in an enormous oak tree, a massive branch cracks under its own weight. It falls. The physical trajectory of that branch is governed by the positions and momenta of countless atoms, each one embedded in a quantum mechanical description. The moment the branch begins to move, the full quantum state of the system, the branch, the air molecules surrounding it, your body, the ground beneath your feet, begins to evolve according to the Schrodinger equation. The mathematics contains multiple trajectories. In some of those trajectories, weighted by their probability amplitudes, the branch passes 1 meter to your left. In others, it passes 2 meters to your right. In some, the weight and the angle and the precise position of your foot combine to place you directly beneath the descending wood. You feel the wind of it passing your shoulder, your heart pounds, your hands tremble slightly. You stand there breathing hard and you think, I was fortunate, that was close. The catastrophic alternative, the one where the branch connected, has simply vanished. It belongs to the past that did not happen. This is what every biological intuition in your nervous system tells you with complete conviction. But the Schrodinger equation contains no mechanism for that vanishing. The mathematics does not include a term that erases the other branches. The other weighted solutions to the wave equation do not disappear. they continue to evolve forward in time. This is the central insight of the interpretation of quantum mechanics proposed by Hugh Everett III in his 1957 doctoral thesis at Princeton University. Everett looked at the Schrodinger equation and asked a question so simple and so devastating that it restructured the entire conceptual foundation of quantum theory. He asked, what happens if the equation is always true? What if the wave function never collapses? What if the mathematics means precisely what it appears to mean? The answer is the many worlds interpretation. When the branch falls and the quantum mechanical description of the system contains multiple weighted outcomes, the universe does not select one and discard the rest. Physical reality branches. Every possibility encoded in the wave function continues to evolve, but the different outcomes evolve along trajectories that become isolated from one another through a physical process called decoherence. Decoherence is the mechanism by which the fragile quantum superpositions of microscopic systems become entangled with vast numbers of environmental particles, air molecules, photons, thermal vibrations in the surrounding matter, until the different branches of the wave function lose the ability to interfere with each other. Once two branches of a quantum state become sufficiently entangled with different environmental configurations, they can no longer combine and produce interference effects. They evolve independently. They become, for all physical purposes, separate realities. Think of it this way. Imagine holding two ripples in a perfectly still pond. While they remain isolated from the surrounding water, they can overlap and amplify or cancel each other, producing the interference patterns that reveal their quantum nature. But now pour that pond into a turbulent ocean containing 10 to the power of 23 interacting molecules. The ripples become hopelessly entangled with the surrounding complexity. Their ability to interfere with each other is not merely suppressed. It is lost at a time scale so fast it is almost impossible to visualize, something on the order of 10 to the negative 23 seconds for macroscopic objects at room temperature. The branches of the wave function become operationally separate. They no longer communicate with each other. And this is why you do not walk around experiencing yourself as a quantum superposition of alive and dead. Each branch of the wave function contains observers who are fully conscious, fully functional, experiencing a single definite outcome. The branch where the falling wood missed you contains a version of you who felt relief and walked away. The branch where the falling wood connected contains a different physical trajectory, one that diverged at the moment of decoherence, one in which your biological pattern underwent a catastrophic and irreversible failure. Both branches are solutions to the same equation. Both branches are physically real under the mathematical framework that Everett proposed, and that a significant number of contemporary theoretical physicists now consider the most internally consistent interpretation of quantum mechanics available to us. Now take this one step further. The branch where the wood connected is not a single branch. The quantum mechanical description of a heavy falling object striking a human body contains its own superposition of outcomes. The precise angle of impact, the distribution of force across bone and tissue, the subsequent cascade of biological events, all of this is governed by the same linear Schrodinger equation. The subsequent branching produces an entire spectrum of physical trajectories. In some of those trajectories, the damage is catastrophic and immediate. In others, it is severe but survivable. In still others, a sequence of physically permitted but highly improbable events, the precise way you fell, the specific distribution of force, produces an outcome that permits continued biological function. This branching is not occurring only when dramatic external events impose themselves on your life. It is occurring continuously, at the cellular level, at the molecular level, at the level of every quantum mechanical process taking place inside the 3 pounds of electrochemical machinery inside your skull. Every time a cosmic ray ionizes a molecule in one of your cells, the quantum outcome of that interaction branches. Every time a single photon is absorbed by a molecule in your retina and initiates a cascade of biochemical events that ultimately become a visual perception, the quantum state of that system branches. Every heartbeat, every molecular interaction, every moment of biological continuity is supported by a foundation of continuous quantum branching happening at a rate and scale that staggers the imagination. The mathematical consequence of this continuous branching is not comfortable to sit with. The number of branches leading to outcomes in which your localized biological pattern ceases to function is not small. It is enormous. The distribution of branches across the full, many-world structure of quantum reality contains vast numbers of trajectories in which you died in an automobile collision years ago. Vast numbers in which a cellular mutation cascaded into a fatal illness before you reached middle age. Vast numbers in which a random sequence of quantum mechanical events produced a sudden biological failure that terminated your trajectory without warning. You have not been fortunate enough to avoid all of these outcomes. You have been located by the physics of decoherence and the structure of the wavefunction in the subset of branches where your neural architecture is still functioning at this particular moment. The distinction is not philosophical, it is mathematical and structural. This brings us to the deepest and most disorienting insight in this entire framework. The reason you only experience branches where you survived is not because the other branches are somehow less real or less physically substantial. It is because the structure of conscious experience requires a functioning biological system to generate it. A branch in which your neural architecture has ceased to function is a branch that contains no observer capable of registering experience. The biological consciousness that would have occupied that branch is no longer present to observe anything at all. This is not a philosophical sleight of hand. It is a structural consequence of the physics. The set of branches that you have access to, the set of branches from which your experience is drawn, is filtered by the requirement that your biological system is sufficiently intact to produce experience. This is a form of selection effect operating at the level of quantum branching, and it means that from the inside, from the perspective of any observer embedded in the many-world structure, survival always feels continuous and unbroken. Discontinuous branches are simply not available to that observer. They are not absent, they are inaccessible. The physicist Brandon Carter articulated a related principle in a different but deeply connected context. The observation that the physical constants of the universe appear structured in ways that permit the existence of complex observers. His point was that any observer, by the mere act of existing and observing, has already passed through an enormous selection filter. You cannot observe a universe that does not permit observers to exist. The many worlds branching introduces a temporal version of this same selection effect operating on a moment-by-moment basis. You cannot experience a branch in which you are not present to experience it. The consequence is a particular and deeply counterintuitive bias built into the experience of any observer navigating a branching quantum universe. From the inside, your path through the many worlds looks like an extraordinarily improbable sequence of survivals. The branch falls and misses you. The car swerves in time. The cellular mutation is repaired by the biochemical machinery of your immune system. The blood clot dissolves before it causes irreversible damage. Each of these events reduces the number of available branches in which you remain present, and the branches that do remain are the ones in which the improbable sequence of continuations persisted. Your experience of being alive at this moment is not evidence of fortune. It is a mathematical artifact of the structure of branching and the observer selection effect built into the physics at the most fundamental level. This reframes the nature of biological death in a way that is simultaneously more precise and more structurally strange than the ordinary picture. Death in the many worlds framework is not an event that approaches you from the future in the way ordinary language implies. It is a property of specific branches of the wave function. In some branches, your biological pattern has already dissolved. In the branches where you currently reside, it has not yet. The question of whether you will die is not a single question with a single answer. It is a question about the distribution of branches in your future light cone, about the probability amplitudes assigned to the different quantum trajectories extending forward from this precise moment. The branches that lead to biological termination are not waiting for you in the future in the sense of a fate that approaches down a single track. They are adjacent realities already physically differentiated from the branch you currently occupy by the accumulated decoherence of every quantum event between this moment and the moment of divergence. You and the version of yourself in that adjacent branch were identical one instant before the decoherence event. Now the two of you are separated by a gulf that no physical process can bridge, evolving forward along parallel trajectories in a space of possibilities so vast that human intuition has no adequate category for it. What the Schrodinger equation is telling us, with the full mathematical weight of the most precisely tested theory in the history of science behind it, is that the universe does not operate on a single track. Physical reality is not a single thread running from the past to the future. It is a structure of staggering geometric complexity, a proliferation of branching histories, each one as physically substantial as the one you are inhabiting, each one containing observers who are as convinced as you are that their particular trajectory is the one true history of the world. You are not special in having survived to this moment. Every observer in every branch who is still capable of observation has the identical experience of continuous survival. The selection filter does not distinguish between branches. It operates identically in all of them. Every observer has looked back across their history and seen an improbable string of continuations and felt that their particular path must mean something. The physics does not support that conclusion. What the physics of the many worlds interpretation offers is something stranger and more mathematically rigorous. You are the debris of an infinite branching. You are one of an uncountable number of localized biological patterns scattered across the vast structure of a many worlds universe, each one experiencing its own unbroken narrative of continuation, each one reaching this same realization at this same moment, in adjacent branches of the same wave function, diverged beyond the possibility of reunion by the irreversible thermodynamic arrow of environmental decoherence. The falling branch missed you in this branch. The mathematics of the Schrodinger equation already contained the adjacent branch where it did not. Both branches are written into the physical structure of the universe with equal mathematical weight. The version of this moment in which you are not here to read these words already exists. It is already unfolding in a region of configuration space that decoherence has placed permanently beyond your reach. That is not metaphysics. That is not speculative fiction. That is the raw mathematical consequence of taking the most successful physical theory in the history of science at precisely its word, following the linearity of the wave equation wherever it leads, and refusing to insert an ad hoc collapse mechanism for which no physical evidence has ever been found. The universe does not delete possibilities. It generates them continuously at every scale, at every moment, without exception. And you, in this particular branch, in this particular arrangement of atoms and fields that calls itself a self, are simply the version of the wave function that is still here to notice.